Hello, everyone. We are Team 3, and our goal for the past 2 semesters was to create a contactless interactive solution to limit the spread of COVID-19. We are a team of 6 electrical engineers and 1 mechanical engineer. The importance of our design is to create innovative technologies that can provide touch-free interaction with elevators to prevent the spread of COVID-19. This is important because many inconveniences and stress has been added to people's lives, and any way that we can limit the spread of the virus is a good thing. Our solution is to provide touch-free technologies on elevators. We chose to create a mini elevator and implement 4 solutions. As previously stated, we chose to focus on 4 solutions, and these were a voice command system, foot pedals, sensors, and leap motion technology. In the first semester, we accomplished basic prototypes that provided proof of concept. In the second semester, we tied all 4 designs into one design and assembled a mini elevator prototype. The rest of the presentation will explain this in depth.
For our first design in the last semester, we implemented a voice recognition system that's ultimate goal is to prove the concept of voice command technology, to operate different elevator functions instead of the traditional touching of buttons for that command. We have successfully accomplished and implemented a hardware and software plan, a working Python code with a GUI interface, and a voice recognition library, and lastly, demonstrated a simulation on the Raspberry Pi LCD screen. After developing the voice command this semester and resolving the errors and challenges encountered last semester, we have successfully managed to create a GUI system that combined all of our 4 functions and will act as the main user command interface for the system, have the elevator move mechanically with the voice command, and implemented an activation phrase for the system, which is hello voice command, to avoid delays and errors in the system. On the right side, we can see the GUI user command interface for all of the functions.
Voice command. Number 2. Number 1. Voice command.
The second design we implemented on the elevator was the leap motion. It is a motion sensor that recognizes hand gestures from a certain distance. In the first semester, we implemented a 7-segment display with a push button to prove that we can contactlessly push a button using only our hand gestures. In semester 2, the leap motion sensor will be used to push a button on our GUI display. We successfully transmitted a signal using hand gestures to push a button, and in turn, the elevator moved to our desired and chosen floor mechanically. The leap motion. We're currently in floor 2. We're going into floor 4. Now we will go to floor 3 and 2. The leap motion.
The third function we implemented into our design was the PIR sensor to call the elevator between floors rather than pushing a button. For the first semester, the goal was to wave our hand in front of a sensor to light an LED to prove that we could send a non-contactless signal that acted as a button being pressed. In the second semester, rather than use a PIR sensor, we used an IR sensor due to sensitivity reasons and implemented the code for it. The following video proves that we were able to wave our hand in front of a sensor and call it to that corresponding floor.
Here we are demonstrating the IR sensor by waving our hand to the desired floor, which in turn closes the elevator. Now we are going to floor 4 and 1 at the same time.
The fourth function we implemented into our design was the foot pedals. The goal of this in the first semester was to open the door and hold the elevator door open and close the door. We were able to successfully accomplish, as you can see in pictures. For the second semester, due to feedback we received from our stakeholders, Chief Phipps, we changed the design and implemented the foot pedals to go between floors. One pedals is to incrementing the floor up by one, and one pedal is to decrementing the floor by one. And one button is to confirm the operation and sending the command. The attached video shows this working successfully.
Here is the foot pedal demonstration. We are currently in floor 1. We are going to the third floor. After choosing your wanted floor, you would have to confirm your desired floor by pressing the confirm button. As you can see in the display on the bottom right corner, the third floor button lights up. Now let's choose the second floor.
As you can see here on the screen, here are our final screenshots of the design. While we focused heavily on the electrical components in the presentation, there was substantial time and efforts put into the mechanical aspect of this system. The entire assembly had to be created inside of an auto inventor. Parts needed to be machined with tight tolerance. Limit switches had to be incorporated to the shop to stop the elevator at certain places. A servo motor had to be incorporated to open and close the elevator door. A frame needed to be designed for the elevator shaft to slide up and down. Also, a DC motor needed to be utilized to power all of this. We wish we had more time to explain the design in depth because there is so much data to go through. We thoroughly enjoyed designing this project and hope you enjoyed our presentation. Thank you for your time. We hope you enjoyed our presentation project.